definition we studied yesterday was?
Maybe.
F prime at A. Right?
Equals
Oh yeah, that one. A limit of some sort.
F limit as x approaches a f of x minus f of a over x minus a.
All right, well done.
Yay, notes.
Okay. There's another definition that's just as commonly used as that one. Okay, that's based on secant lines, right? Where the next one, make sure I write it down right. Yeah. It's an A. F prime at A is the limit as x approaches h. F at A plus h minus f of A over h.
Wait, that's an h in it now? Or?
Yeah. That's why I didn't start with this
yeah.
one yesterday.
Wait, the one like when it's f prime a or the f prime.
So the derivative at A, this is the second way to do it. Okay. So let me kind of explain the difference between the two.
So on the bottom, just H.
Yeah. Okay, with this right here, basically what we're doing is we're bringing these points together, right, as close as possible to get a tangent line slope. Correct?
Okay.
Okay. That's what we've been studying. With the second one, h is the distance between the two. Okay. So if I have a point here and a point here, this would be h. That's, I wrote that down wrong. That's fantastic.
Hey Mason.
See, on
This is the limit as h approaches 0. Sorry. What happens is h goes to 0. What happens to these points?
They close.
Yeah, they come together and they meet each other, right? So we're still taking these points together, which is a different way to do it.
So then it's.
So what is H?
H is just the distance between the two. It's an x value.
Okay. So this equation would be used.
So this is the x distance between the points. Okay, so there's two ways to do it. One, we can just bring the points together, and the other, we can leave one stationary and take the distance between the two to 0. Okay. Different methods, they both work. Okay, sometimes one's better than the other. Yes.
Well, you answered that. In the when you introduce this one, is that f prime a at the very start?
Yep. It is. And we're still going to have, it's the same basic procedure. We're still going to have algebra when we solve this. Our goal is to get rid of the h's, is what we're looking at. Okay. So it's still going to be an algebraic limit. It's just a little different. All right, let's try one. Compute. F prime at 3, where f of x is x squared minus 8x. Board. Right. Right, again, when you do these problems, write that definition down every time. So we need f prime at 3, right? So that's the limit as h approaches 0. F of 3 plus h minus f of 3 over h. Okay, every time there's an a, we replace it with 3, right? So that's what we need to do. You with me so far? Okay, now let's do the math.
Is f of 3 plus h the same as f of 3 plus f of h?
No.
Okay, then what is
Okay,
it?
remember when you evaluate a function, this whole quantity goes in for x.
Oh, okay.
So it's
3 plus h.
3 plus h squared minus 8 times 3 plus h. Right? You're just evaluating a function. So plug 3 plus h in there. And then f of 3. What's f of 3?
9 minus 1624, which is 13, negative 13.
Let's try 15. Good? Do you know why I put plus?
Negative.
Do it a little more obvious here. Subtract negative 15. Right. So minus negative 15. So are you comfortable where we got all that? Okay, where are you stuck?
Okay,
No
so,
clue, I'm such
Okay.
an issue.
oh, you.
Cover that. F of 3 plus
G
h.
plus 3, okay, I see now.
I took this is our x.
Yeah,
I put it in everywhere there's an x.
okay. There we
Right
go.
there.
I thought our first
Thank
was
you.
Okay, so yeah, everywhere there's an x, I put 3 plus h. And then f of 3, everywhere there's an x, I put a 3. We get a number that time. Okay,
Wait, so what's f of 3? Like negative 15?
yeah, so it's 3 squared minus 8 times 3. You get the math.
And then you distribute the 8.
Yep, now we have some algebra. It's an algebra problem now.
Equal those one.
Yep, you got to FOIL here and distribute here.
So do the H plot.
Say what?
Where do the H plot?
It's just h.
So,
We're going to cancel it out eventually, hopefully. Right?
here's the goal.
We get rid of it, because we don't like zeros in the bottom, right?
No,
So we're going to get rid of it. All right, what's 3 plus h squared?
9 plus 6h plus h squared.
Minus
24.
24. Minus 8h, yeah, be careful there. Plus 15, right? Oh, we combine like terms?
9 plus 15 is 24. 24 minus
Yeah.
24 is nothing.
9
They cancel.
minus 24 plus 15 is 0.
Yay!
That's the hope. Okay. 6h and 8h, what do we get? Yeah. H squared minus 2h. And almost there. Now you can see if factor an h out, right? boom. What's our answer? Yep. Now you can plug 0 in. Good answer. Right. So this is an algebra problem. It's a calculus problem, but it's mostly algebra, right? The calculus is knowing what that means. What does that mean? Yeah, what does that number mean? The
F
F
prime
slope of the tangent line to F at what value? X equals 3 is negative 2. Okay, so be careful there.
Yeah, that's what okay. That's what we.
That's what that means. That's a calculus interpretation now. Okay, so mostly an algebra problem, but knowing the meaning behind it is calculus stuff. Okay. So the slope of the tangent line to F at x equals 3 is negative 2. Get used to writing very specific statements, such as that. Because if I left any one of these items out, that's an invalid statement. You have to have all those items in there. All right. What is the equation of the tangent line? Yeah, we like to work in point slope, right? The slope is negative 2. We just need our point. Okay, the x value is 3. What's the y?
0.
F of 3 is negative 15, right? There's your equation. And if you need to, you can write f of 3 is negative 15. F prime at 3 is negative 2. Those are the two pieces of information you need. All right. Does anybody know if I assigned any trig problems? Yeah. What did I assign? 1, 7? Or what numbers did I assign?
3, 7,
Okay.
11 through 15,
Okay.
19,
Okay.
27,
Keep going.
45, and then page 57, 12, 26.
Okay. So no, none of those. Okay. So you've got the two limit definitions, right? Let's talk about where derivatives may not even exist. Okay.
I probably should have done that. Wait, what do you mean can't exist?
Okay, let's call this some function. It's a piecewise function, right?
That's freaking equal.
It kind of does. There are 2 points on that graph where the derivative does not exist. Any ideas?
0.
Well, it's this
What's the slope of that line? 0, so we're okay in here.
Is it
There's somewhere there's not a slope, right? Derivative is slope, is there somewhere there's not a slope?
Yeah, the point. Yeah.
What point?
Is that an arrow or is that a point at the end?
Here?
That point.
The derivative would exist there, actually.
from where it starts to go?
Oh, it has a negative slope.
Is it
Yeah, you still have a slope there.
The middle of the
You
parabola.
still have slope?
Right there.
Yeah.
What's the slope?
0.
0, we're still good.
So when it's falling.
It's
It's
at the very end of the,
it's at the end
it's the flat part.
The slope is 0, we're still good. Is there anywhere there's not a slope?
Is it the vertices when it's like instantaneous stopping?
Hey.
Oh.
That's not what I heard. Those two spots where the derivative does not exist.
It's okay. Alex,
Okay. So if we're thinking in terms of slope, if I come from this direction, the slope's positive, right?
So whatever the slope
And if I come to here, the slope is 0. Are those the same? No. Okay.
So if that was
So,
a curve,
and
would it?
you could also think about it, how many tangent lines could I draw to that point?
A lot.
An infinite number. Because I can draw that one, I can draw that one, they're all tangent, right? So the derivative does not exist at corners. Okay.
So if it's not continuous, if the slope is not continuous.
Yeah, that's exactly what it is, actually. Yeah. Yeah.
So if that
In
was a
in
curve,
layman's
then-
words, the slope has to be continuous. The derivative has to be continuous for the derivative to exist. Okay. So corners, we can also have derivatives that don't exist at line birds. It's called a cusp.
It's a bird.
Okay, line birds. Right. And then discontinuities.
No, that makes sense.
Okay, we will formalize this a little bit more, but for now,
They jump
can you recognize it on a graph where we're not differentiable?
All discontinuities or just jumping in?
Yeah, that's
Or jump?
No, any discontinuity. Any.
Oh, because then that, it'd still be discontinuous.
But an infinite here, right? There's, derivatives are different from both sides, positive versus negative. Even this, not differentiable at that point. So you're looking for where does the slope not exist? Right, the derivative not exist. Where does the slope not exist? I find it much easier to think of derivative in terms of slope because you've always worked with slope. Okay. Any questions? All right. That's it for me.
Wait, what? Oh.
Now we finish the
Class is almost over.
Well, I know, but.
Yeah.
I ran out of room on the first page.
Do you need me to write the homework down again?
Yes, please.
Okay. I will go.